Good morning, guys. Today we are going to be learning rational numbers, and this is module 4.4. So let's look at our learning target. I can order rational numbers and understand that the absolute value of rational numbers shows their distance from zero. And our vocabulary for this lesson is rational numbers. So let's talk about what rational means, all right? But I'm going to show you a little diagram so that you can understand what each kind of format of the numbers mean. For example, what are natural numbers, what are whole numbers, what are integers, what are rational numbers, all right? So let's start with the basic, and the first thing I want to talk about are real numbers. And real numbers or natural numbers, natural numbers are the ones that are, I'm going to start from the bottom, and we have natural numbers. And natural numbers, these numbers are like 1, 2, 3, 4. All the counting numbers that we have, that's what natural numbers are. So for example, I can have 4, I can have 10, I can have 9. These are all natural numbers, all right? And then the next level up, we have whole numbers, okay? And the whole number, so I'm going to put it like this. So these are all subsets within rational numbers, all right? So we have the natural numbers. The next up are whole numbers, all right? So because we can see that natural numbers were 1, 2, 3, 4, etc., right? So whole numbers they have all of the natural numbers plus they have a 0, okay? So in whole numbers, we have an addition, which is 0. Okay, so then natural numbers once again are 1, 2, 3, 4, counting numbers, and then whole numbers is 0, 1, 2, 3, 4. All right, and then the next thing that we have, I'll just make it like this. All right, this is integers. Okay, so integers is what comprises of natural numbers, whole numbers, and now we also have a set of negative and positive numbers. So they are continuing without an end. So literally, you write it as a set, and I'm just going to show you what integers means. So you have a set like this written out, and within the set you'll have the dot dot dot, because that means it is continuing. There's no ending. And then -3, -2, -1, 0, 1, 2, 3, and again dot dot dot, and then this subset, the set closes. All right, so this is what integers are, and they are any number from this set. And where the dot 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 means what? This means that this is continuing without an end. All right, and then the one above this, now I'm just going to put this like this, all of this, and then we have something in which any number that can be written as a fraction, because look at what this says. It says rational. So look at the part which is ratio. Ratio means that I can write it as a fraction format, A to B, and that is what a rational number is. All right, so this is rational numbers. This whole thing is rational numbers. All right, and in this we can have things like 1/2, for example. All right, we can have 2 1/4. We can have 4/500. I can have 18%, because I can write 18% as a fraction. We've done that, 18/100. All right, -3/4. So these are all rational numbers. For integers, yeah, I had put it here. I can just put some examples over here. I can have -8. I can have -3. So this is what makes it an integer. All right, now even numbers which are repeating decimals, they can be converted to a fraction, all right? So repeating decimals also can be under this format of rational numbers because I can write it into a fractional form, which you will learn about later on, all right? Now, the next thing, let's talk about graphing rational numbers on a number line. So let's say if I give you a set, because they are written like this, and I give you 2 and 2500. I give you -1 and 3/4. Okay, -1 and 3/4. And I give you 0. And here's my set. And I ask you to graph that. So rational numbers and sets of rational numbers can be graphed on a horizontal or a vertical number line. And we always write rational numbers within these braces like I have done. Okay, these are the braces and I write rational numbers within this. To graph a rational number on the number line, we are going to place a dot at its location. So let's look at this. And I'm going to go ahead and I'm going to make a number line. All right. So if I have a number line, this is my number line. Okay. I'm going to go ahead and just erase this so that you can see. All right. Right. And I am going to go ahead. I have 0. Right. And then I'm going to put 1, 2, 3. And then on the left, we know we have negative integers, -1, -2, -3, etc. All right. And then I'm going to place a dot. So look, because I have 3/4, I'm just going to break it apart into 4 parts because I also know that 2500 is a quarter, right? So I'm just going to break these apart into 4 parts so it's easy for me to graph. Each of this will have 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Okay? So if I'm saying 0, show you with a different color. You basically go to the number line, you look at where 0 is and where that little index over here where it's like cutting the line segment. We go here, put a little dot and circle it. So that is 0. Okay, and then let's look at 2 and 2500. So I know that this is 2, this is 2500, this is 5000, this is 7500, and then you have 3. So 2 and 2500 would be here, and I put a little circle around it. And that's how I graph it. All right, and then if I have -1 and 3/4. Now we know that the 0 acts like a mirror and the reflection is going to be like opposite on the other side. So if I have 1 and 3/4, if it's positive, it'll be here. 1 and 3/4 would be here. But on the other side of 0, it's going to be flipped. So it's going to be on the other side, right? So if I have -1 here, this would be negative. Please remember, don't write fractions backwards, okay? So in this case, yeah, this is -1 and 1/4, -1 and 1/2. And then this one here, this is what would be -1 and 3/4. All right. Now, just be careful with this because we are so used to seeing fractions as, you know, this being 1/4 and 2/4 and 3/4. And so you don't want to write it like that over here or graph it like that. Okay. So remember that on the other side of 0, it's going to be like a mirror and it is flipped. All right. But that's how we graph the rational numbers on a number line. All right. So let's go ahead and graph some of the rational numbers. So let me just take you to my board where I can have the question and then we can graph over here directly. So it's saying graph the set of rational numbers and is giving you that set on the number line. Okay, so first what I'm going to do is I am going to find, all right, here we go. Just change this to color black. All right. So first what I'm going to do is I am going to find the integer boundaries of the set. Okay. And so the values in the set are lying between, so what is the integer which is going to the left of this? Going to be -2, right? And to the right of this fractional part, this mixed number is going to be 3. So my integer boundaries, the values are lying in the set between -2 and 3. All right, so this is what I need to identify first. And then I'm going to graph the rational numbers. And once again, to graph the set, it is helpful to rewrite the fraction and mixed numbers as decimals in order to find the location on the number line. So if I look at this one, -1 and 1/5, okay, I can change this to a decimal, right? In order for me to change it to a decimal, I need to see that my denominator is either a 10, 100, 1000, etc., because then I can read that as a decimal. So if I do 10 over here, remember this is negative because I get 5 times 2 is 10. So same thing over here, and I get 2. And what is -2/10? It's exactly how I say it, is how I'm going to write it. And so this is to -2/10. Okay, so I'm going to write that fraction as a decimal first. Now, let's look at 2 and 3/5. I'm going to write that on this other side so that you can see. All right, so if I have 2 and 3/5, I am going to change this again. And so I have 2, and then I'm going to change the 5 to a 10. This is times 2, and this is times 2, and I get this. All right, so what is this? This is going to be equaling 2 and, how you say it, 6/10. So here is my decimal format, okay? So I've changed all of them to the same format. This is -2/10. This is 2 and 6/10, and the others are already in the decimal form. All right, so next I am going to make a number line. And I know that, what did I say? That the integers are between -2 and 3. So I'm going to make a number line. All right, and I have 0 here, 1, 2, and this is 3. And I have -1 and -2. But that's all I need, because that's where, as I said, this is where my numbers fall between this. Okay? Now, let's look at this, and we are going to graph, first and foremost, -1/5. -1/5 is what? -2/10. So what I can do is, I can just break it into 5 parts, but I do know that if this is 0, okay, so this is like if I say 1, 2, 3, 4, 5, this will be -2/10, 4/10, 6/10, 8/10, so all negative, and then that is -1, right? So if I am plotting, and let's say I put all of them into 5 sections, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, and 5. Each is like, 2/10, 4/10, 6/10, 8/10, and of course, 1 whole. All right. So if I am graphing, let me go ahead and use this color now for graphing. And for -2/10 or negative, which is -1/5, it's going to be here. All right. So this is my -1/5, because that is what I converted as -2/10 to make it easy on myself. All right. Then if I have -7/10, that is going to fall, because 2/10, 4/10, 6/10, and 8/10, right? So -7/10 would be in the middle of -6/10 and -8/10. So this is my -7/10. All right. Then we had 2 and 3/5, which is 2 and 6/10. So look, this is 2. Now that's a positive integer or positive rational number. So it's going to be to the right. Okay. So I have 2 and 3/5. So this is 1/5, 2/5, 3/5, which is going to be here. All right. So this is 2 and 3/5. All right. And then we have -1 and 8/10. So if this is -1, this is -1 and 2/10, -1 and 4/10, -1 and 6/10. This over here, this is going to be my -1 and 8/10. All right, so that is how we graph all the numbers on the same number line. So these are all the rational numbers being graphed on the same number line. So once again, it is helpful to change them into the same format. It becomes very easy if you can see them all in the decimal form. All right. The next thing I want to quickly talk to you is about absolute value of rational numbers. So let's say if I have a rational number which is 2 and 5/10. So let's say I have a rational number which is 2 and 5/10. Okay, so let me use this other color to show you. So if I have 2 and 5/10, this is 2/10, 4/10, this is 6/10. So 2 and 5/10 would be over here. Okay, so this one here, this is my 2 and 5/10. So there's my rational number. All right, now we are looking at absolute value. And what does absolute value mean? So it is basically the distance of a number from 0. So just like we had absolute value of integers, it's, you have the distance of, let's say, 2 is 2 units away from 0 on the number line. And so is the distance of -2. -2 is also just 2 units away from 0 on the number line. So absolute value is nothing but the distance of a number from 0 on the number line. All right, so if I'm looking at 2 and 5/10, we're looking at how far is this, and this is how much? 2 and 5/10 units, right? And so then we're looking at, okay, what's another number, because always the two numbers have always exactly the same absolute value. One on the right side of 0 and one on the left side of 0. So they will be the same distance from 0 on the number line. So this rule applies to all numbers. And so for rational numbers, if I have positive 2 and 5/10, what is going to be the absolute value? So what's the opposite of 2 and 5/10? So look, if I go to the left, and let's say this is my -3. All right, so if I have that distance from 0, look, I'm going to go the same distance here. This is halfway between -2 and -3. So this is also going to be 2 and 5/10 units on the other side. And so rational numbers, again, if you have 2 and 5/10 and you have -2 and 5/10, they are each 2 and 5/10 units from 0, even though they are on opposite sides of 0. And numbers that are the same distance from 0 on a number line have the same absolute value. Okay? And so how is absolute value written? It is written like this. This means absolute value of 2 and 5/10 and absolute value of -2 and 5/10. So my absolute value is going to be positive. All right, because distance is always positive. All right, so I wanted you to see that. All right, so next thing, let's find absolute value again. And let's look at this one. All right, so the lowest point, okay, trying to get to the, all right. The lowest point in a certain cave has an elevation of -53 and 4/10 meters. If the cave entrance has an elevation of 0 meters, evaluate the absolute value of -53 and 4/10 to determine the number of meters a hiker would descend to reach the lowest point. All right, so if I have this, I can go ahead and I can graph negative 53 and 4/10 on a number line. Oops. So I'm just going to pull this down so you can look at it. All right, so if I can graph it. All right, and there is my graph. I'm just going to show it to you, make it easier for us. All right, so once again, I have my 0, and it's going in intervals of 5, as you can see. All right, and to the left of 0, obviously, because that is where negative 53 and 4/10 would fall. All right, and so how many units from 0 is negative 53 and 4/10? Okay, so we are looking at this distance from 0. So look at this distance. This distance. All right, and if I'm looking at that distance, what is that distance? It is 53 and 4/10 meters. That is what my distance is. All right, so the hiker descended 53 and 4/10 meters. All right, hiker descended that much. All right, now the next thing I want to quickly talk to you about is comparing rational numbers. Okay, so let's look at this really quick when I'm comparing rational numbers. To compare two rational numbers, you can compare the signs as well as the magnitude or size of the numbers. All right, now if the signs are different, we know that the positive number will always be greater than the negative number. All right, and then for example, if I have 1 and 5/10 and negative 1 and 2/10, all right, so the signs are the same or not. One is negative, one is positive. So of course they are different signs, right? And so to compare the signs, a positive rational number will always be greater than a negative rational number. So positive will always be greater than a negative, all right? So as we can see in this case, I have 1 and 5/10 because it's positive, it will be greater than negative 1 and 2/10. Now what happens when the signs are different? All right, so if the signs of the two rational numbers are the same, okay, the signs are the same, you can graph the numbers on a number line to compare them. And if the numbers are written in different forms, it may help to graph the numbers if they're both written as decimals or they're both written as fractions. You want to put them both in the same format. Now, here's a trick that I'm going to teach you. All right, so if I have two negative numbers, for example, for positive, we know that, you know, whichever number is to the right on the number line is the greater number. But if I look at positive integers, positive rational numbers, let's say I have 1 and 5/10 and I have 1 and 2/10. So if I'm looking at the positive, okay, so when I'm looking at positive, I know that 1 and 5/10 is greater than 1 and 2/10, okay, because this is going to be on the right on the number line. Now, when the numbers, the signs are going to be both negative, what I would always do is start with positive and then do one thing. All right, so in this format, it was 1 and 5/10 was greater. Then what happens if these are negative? Both of them are negative. All right, now I did tell you that when we go to the left of the number line, the order is going to flip because it's like a mirror, right? So what I would suggest is start by writing both positive, and when you go to both negatives, this is what you do. Take that inequality and just flip it. So now look, when it's negative numbers or negative rational numbers, negative 1 and 2/10 is going to be greater than negative 1 and 5/10. So that's a really easy way to think of this. Now think of the graph at the bottom, and why we are saying that, all right, is because we know that on a number line, whichever number is to the right on the number line is the greater number, right? So if you can see over here on the negative side, all right, we have negative 1 and 2/10, which is on the right of negative 1 and 5/10. And so that is why negative 1 and 2/10 is greater than negative 1 and 5/10. Okay, so let me just show you this with the, so look, there we go. But once again, my suggestion, look at those both the numbers as positives first, and then when we are changing it to negatives, you just flip the inequality, and that makes it very easy for you to understand. All right? All right. So next thing, let's compare rational numbers some more. All right, and so if I go here, let's look at this one. We are comparing 5100 and negative 5100 and negative 12 and 2500. All right, so the first thing that I need to do is I need to put both of them into the same format. Okay, so decimals is always easy. You can do both in fraction form. That is a personal preference, and that is perfectly fine. But to compare them, please put them in exactly the same format. All right, so I'm going to change them to a decimal. I already have this decimal form. Okay, so I'm going to change this to a decimal format. So I have negative 12 and 2500. Since this is 51, negative 5100, that means my denominator is what? It's 100, right? So I'm going to do the same thing to this, and I'm going to make my denominator 100. And this is negative. So 25 times what gives me 100? 25 times 4. Whatever I do to the denominator, I do exactly the same thing to the numerator. So I'm going to do times 4, and I get 12 times 4, which is 4800. So now look at my decimal. I have negative 5100 and I have negative 4800. Negative 4800. All right, so here's the thing. If I was graphing this on the number line, of course I can see which is on the right, but let me tell you one more thing. We are going to use the trick that I just taught you. We're going to look at both the numbers as positives first. Okay, so if I have in the positive format, if I have them both in the positive format, and I have 5100 and I have 4800, which is greater in positives. Of course, the bigger number would be 5100 than 4800, right? Now, when both the signs have become negative, so here we go. When both signs have become negative, all right? So we have negative 5100 and we have negative 4800. What did I say you need to do to the inequality? We are going to flip the inequality. So look what happens now. Okay, when it's both negative rational numbers, so you can see negative 4800 is going to be greater than negative 5100. And what is negative 4800? It's negative 12/25 is going to be the greater number. But if I was to graph this, I would make a number line. All right, and what I'm just going to go ahead and do is I'm going to do 0, and then I have negative 1000. Okay, I'm trying to go to the next integer, which is negative 1, but then I'm going to have 10 parts in between. All right, so this is negative 2000, negative 3000, negative 4000, negative 5000, negative 6000, negative 7000, negative 8000. Okay, and that's the decimal over here. Negative 9000, and then we have the negative 1. And I'm trying to show it this way so that it becomes easier for me to graph. And I can see that we have negative 4800. So that is going to be over here. All right, let me use a different color. All right, So if I see negative 4800, I know that this is negative 40 and that's negative 4000 and that's negative 5000. Okay, this is negative. So negative 4800 is going to be over here. Okay, and this one here, this is my negative 12/25. All right, and then negative 5100 is going to be between negative 5000 and negative 6000. So this is going to be over here. Okay, so this is my negative 5100. So let's look at these two. Which is on the right? The negative 12/25 is on the right on the number line compared to negative 5100. And so that is why that is the greater number when we are comparing these. Okay? Now, when we have to order rational numbers, you want to again put them in the same format, because you are going to get a set of rational numbers. You want to put them into the same format of all decimals or all fractions, and then it becomes simple to put them in the correct order, and you can always use a number line for that purpose also. All right, so we are going to write each number in the same form. Since there may be different denominators in the fraction, it may be easier to write all of the numbers as decimals. Okay, so that always works out. So let's look at these steps. All right, let's look at these steps. So to order rational numbers in the same form, since they may be different denominators, it's easy to write all the numbers as decimals. Okay, use the signs of the numbers. That is important. Whether it's positive, is it negative, the place value, or a number line to compare the numbers. So many ways to compare. All right, and then you order the values from least to greatest or greatest to least based on what the question asks. And let's look at this set of numbers over here. I have 1/4, I have negative 375,000, I have negative 17/50th, and I have 3/10. So there are several ways this can be done, but I'm just going to show you on the number line really quick. So look, here we go. All right, and so I have the greatest one over here. I know that I can see 3/10. All right, so the integer to the right of it is going to be 1. Okay, and then I see negative 375,000 or negative 17/50th. That means all of these are less than negative, not less than, but greater than negative 1 as the integer. So the two boundaries that I'm looking at is negative 1 and I'm looking at 1. All right, and then I'm breaking it up into 1/4. So 0, 1/4, 2/4, 3/4, 1. Same thing on the left. Okay, and then of course I'm going to change them to the same format, and I can see that on the extreme left I have negative 375,000, and then I have 17/50th, I have 1/4, and I have 3/10. Okay, so when we are putting it in the correct order, that is the form. And now let's work on a problem to see how we can put them in exactly the same order. All right, so let's do an example how we can change them all to the same format, and that's what we're looking at. All right, so let's look at this question. It's saying order the set negative 2 and 4600, negative 2 and 2500, negative 2 and 1/10 from least to the greatest. Okay, so the first thing what I want to do is I would like to put them all as a decimal. Okay, so if I'm looking at the first one, it's always easy to put it as a decimal. It becomes easier to compare or graph or whatever. Okay, so here, this is already in decimal form. Okay, so I'm going to change negative 2 and 22/25. So I'm going to change this one into the decimal format. So I'm going to make it, look, this is 4600th. So I'm going to make my denominator also 100 over here. Okay, so I get negative 2, and if I give this as 100, what is this? 25 times 4. Same thing over here, times 4. And what is 22 times 4? I get 88. So if I'm reading this number properly, This is negative 2 and 88 hundredth. So how I'm saying it is how I'm writing it. So look, 2 and 88 hundredth, negative 2 and 88 hundredth. All right. So I've changed that to this format. Let's change negative 2 and 1/10. Okay. So if I have negative 2 and 1/10, this one here, how I'm saying it is how I'm going to write it. Okay, there's my number over there. Now, I can definitely graph the numbers on the number line, but I would also like to show it to you if it was like in the positive format, what I would do. So, if let's say these were all positive numbers. Okay, so if let's say this was 2 and 1/10, this was 2 and 46 hundredth, and this was 2 and 88 hundredth. So let's say these were all positive. I'm just trying to show how the negative flips completely. All right. Now, we know that in order to compare decimal numbers, you want to put the same place values under the same place values, a decimal under decimal. And then we start from the extreme left. Okay. So I start over here to compare. Okay. Is there anything which is different? No. So then we go to the next column. We look to the next place value. Which one is the greatest here? I have this one would be the first, that is the largest. This would be the second, and then this would be the third. Now this is with positive integers. All right. Now let's look at what happens when all of these turn into negative. If it changes into negative, guess what? The order completely flips. Okay, if this all becomes negative, all right, if this all becomes negative, the order is going to completely flip. So we have negative 2 and 1/10, we have negative 2 and 46 hundredth, and we have negative 2 and 88 hundredth. All right, so what was third here? Okay, so if I'm going from, this was the largest to the smallest, right? But if I'm going from least to greatest, we're just going to go, we said this was from greatest to smallest. So if I said it the other way around, if it was this way, least to greatest, which one would have been the least? This would have been the smallest, right? This would have been the smallest, this would have been the second, and this would have been the largest. Okay, so if it asks for least to greatest. Okay, least to greatest. All right, now let's look at this. If the signs are flipped and we're doing least to greatest, guess what? This completely flips also. All right, so this is going to become the greatest now. So this is going to be the third, which is the largest. This is the second largest, and this is going to be the smallest. So look how it flipped from positive to negative. So I wanted to show that to you. That is a format to use. But I want to show you on the number line also. So I'm going to pull this down so you can see the number line, and I'm going to pull this over here. So look. All right. So I have 2 over here. Okay. All right. So this should actually be negative 2. All right. There's a slight mistake on that. So this should be negative 2 over here. All right. And then it's all the way to negative 3. And then if I'm looking at it, I've cut it into 10 parts. Negative 2 and 10 hundredth, negative 2 20 hundredth, negative 2 30 hundredth, and so on, all the way to negative 3. Okay, and based on what I had just done, this is negative 2 and 1/10, because negative 2 and 10 hundredth is also negative 2 and 1/10. Okay, and then negative 2 and 46 hundredth would fall here, and then negative 2 and 88 hundredth would fall here, which is negative 2 and 22 25th. So there is my line graph showing you. And since this is on the extreme right, this is going to be the largest. So if we are going from the least to the greatest, it's going to be negative 2, 22 25th is the least. The next one is negative 2 and 4600th. And the last one is negative 2 and 1/10. All right. So that's basically what rational numbers are and how you compare them, how you order them. And just remember, rational number is nothing but it is a number that can be written as a ratio, and it comes from the word ratio up here in rational, and that means a number can be written in the fraction form. All right, and so and that's about it in this lesson. All right, guys, have a wonderful day.